Alright, in this video we're going to talk a little more alternating series as well as look at some old AP questions. So, first diverge or converge, they're both alternating, so we're going to have to decide if it converges or diverges, and then if it converges, is it absolute or conditional. So, remember, our process, we start with this. We just say, okay, is the limit as n approaches infinity of 3 to the n over n cubed, is that 0? Well, it's a little bit hard to see maybe with this. The answer is no. The limit is actually infinity. But if you didn't spot that, and I think a lot of people would because they'd say, well, that exponential on the top 3 to the n is more powerful than n cubed, so I bet the limit's infinity. But if you didn't have that intuition, you would probably use L'Hopital's rule. You know, because you plug in infinity, you get infinity over infinity. So you would use L'Hopital and say, well, the derivative of 3 to the n is 3 to the n times the natural log of 3. The derivative of the bottom is 3n squared. Now you'd evaluate the limit again, and unfortunately you still get infinity over infinity, so you do it again. 3 to the n times the natural log of 3 squared over 6n. And I mean, at this point, we could do L'Hopital one more time. We'd get 3 to the n times the natural log of 3 cubed over 6. So now you get infinity over 6, which is infinity. So we start by just checking this limit and see if we get 0. If we get 0, we know there's convergence in an alternating series. We have to then decide absolute or conditional. But in this case, the limit isn't even 0. So the answer is that this one just diverges. We don't have to go any further. Okay. Again, looking over my L'Hopital's rule here, just remember that natural log of 3 we treat as a constant, so you can kind of ignore it. So the derivative of 3 to the n is 3 to the n natural log 3, which means we've got two natural log 3's multiplied together. And this is a constant, you ignore it, you find the derivative, and then you got a third one multiplied. Okay. All right, next. Start by looking at the limit of just this. Say, all right, is the limit as n approaches infinity equal to 0? It is. The high power's on the bottom, so the limit is 0. So at this point, I know I have convergence. But I need to decide if it's absolute or conditional. So to do that, I simply take I rewrite the series without the alternating part, and I look at that. Well, polynomial on top, polynomial on the bottom, I would use limit comparison. I would compare to the limit 1 over n. Remember, just using the high powers on top and bottom and reducing it. This is a divergent p series. So limit comparison says, if you remember, that you take the original, divide it by your comparison, I'm going to multiply by the reciprocal, and evaluate the limit. This limit will come out to be 1. As long as you get an answer greater than 0, you have agreement between your comparison limit and the original. Well, my original limit was a divergent p series, so my original must diverge as well. So originally we'd said we had convergence, but if we ignore the alternating piece, we find out it's divergence. So this converges, but only conditionally. All right, these are a couple AP questions. Which of the following converge? Well, the first one, n over n plus 2, I would think of the nth term test. If all you did was focus on this for a second, you said, well, what's the limit of this? The limit of this is 1. So essentially, this is saying I'm just going to keep adding 1 over and over and over again. Now, if you missed that, if you didn't see that, you could use limit comparison. Using the high-powered stuff on top, high-powered stuff on the bottom, you get 1. So again, you're adding up 1 over and over and over again. That's divergent. So this first one, nth term test, or limit comparison, I'll just write nth term. That one would diverge. Let me skip over to number 3. This one, of course, is this one is out. It's a p series, or the harmonic series. It's a constant over n to a power, and that power is only 1. Now, the cosine of n pi, if you think about plugging in n here, you say, well, the cosine of pi is -1. Cosine of 2 pi is 1. Cosine of 3 pi is negative 1. This is, if I can draw it down here, this is essentially that series. Okay? Because all the top is doing is alternating between negative 1 and 1, and then we're dividing by n or multiplying by 1 over n. So remember, with an alternating series, you start by just looking and saying, is the limit of that part, that non-alternating part, is that 0? It is. So we have convergence. 2 does converge. Now, it doesn't converge absolutely because this diverges. Okay, because the series without the negative 1 to the n diverges. But it does converge, and we were just asked which of the following converge. 2 does. All right, next, which of the following diverge? Well, this first one, sine of 2, I don't know what it is, but I know it's less than pi because it's got to be between negative 1 and 1. So this is a number raised to the nth. This is a convergent geometric series. So we're asked which one diverges. This one's out. I'm going to put a convergent geometric just right above there. The second one I could rewrite as n to the 1/3. So this is a divergent p series because it's it's a constant over n to a power, and the power is less than 1. And this last one, e to the n over e to the n plus 1, you could maybe use a couple tests, but I think the easiest way is to just look at this and say, what's the limit as n goes to infinity? Well, e to the n over e to the n, I mean, the limit's 1. So this is essentially like adding 1 up over and over and over again. So this is divergent by the nth term test. So the two that diverge are 2 and 3. The nth term test sometimes gets missed because you kind of go to the other ones right away. And you could use limit comparison here. You know, if you said, well, the highest powered thing on the top is e to the n, highest powered thing on the bottom is e to the n, and, you know, that's like adding up 1 over and over again. Well, adding up 1 until infinity, you just 1 plus 1 plus 1 obviously diverges. So you could use limit comparison as well.